Yeah, so welcome to our first live session where we are going to go through or recap some of the things we have done right or what we have gone through in our lessons when it comes to functions. So you remember that we have looked at functions basically, right? We've considered the concept of functions, and if you can remember the definition of functions, then that will be very fine, right? Or you know how function applies to real life, then it means that you have probably learned something. So in the comment section, put over there what you learned about the definition of function so that we can probably go through them and discuss the definitions that you have. So remember, we used some examples of functions. One of the things that we looked at was when we are considering a ride hailing app. So we mentioned that in a ride hailing app, right? So example, we have a local one. So let's use our own local ride hailing app, Shazzy. We can have the fare, right, in relation to the distance. And depending on the distance you are traveling, that is what will depend on the fare you pay. So we can say that the function f of the distance is equal to p, right? Where d represents the distance, nf, right, is the function which the p will represent the price. So based on the distance, you are going to pay a particular price. So that is a typical practical illustration of our functions. So we know that functions looks at the relationship that exists between things, right? So we see a function assign members of the domain, right? If you have members of the domain, a function assigns members of the domain to members of the codomain, right? So we have D, E, and F. So A can be assigned to D, B can be assigned to E, and C can be assigned to F, right? And we also went on to look at how we can evaluate functions. So if you have two functions F and another function J, right, these functions we can say that define F as a function that can be mapped, right, can be mapped as x squared plus 1. And then we can also have the function G that can be written as 2s plus 3, right? We can decide to do an addition of f plus g. And we mentioned that for f plus g, we can take the f function, which is x squared plus 1, right? Then we add it to the g function, which is 2x plus 3. And that means that we can expand this and have x squared, right, plus 2x plus 1 plus 3. And that implies that our f plus g becomes equal to s squared plus 2s plus 3. So that is basically our function f plus g. So when we have a function, we can write the function as what? Two different functions. When we are evaluating them, we can sum them. And then we can as well multiply these two functions. So we can have a function and multiply f plus g, in this case where we have f multiplied by g, right? And that means that we have x squared plus 1. And then we will also have another function which is 2x plus 3, which is a g function. So basically when we are expanding this, we have s multiplying g to be equal to, right, we pick the s square and then we expand it over 2s plus 3, and then we pick the plus 1, then we expand it over 2x plus 3. So our f times g becomes equal to 2x cubed. Then we have plus 3x squared plus 2x plus 3. So when we group like terms here, we realize that all these variables do not have a like term. So that gives us our what? F multiplied by g. And then we also went to look at composition of function. So we have considered composition of functions, where we have looked at how functions can be composed, right? So if you have f of g, we can write it as f of g of x. If you have h of g of s, you can also write this as h of g. And in English, you can write this as j followed by f. And you can also write this as j followed by h. So for instance, if you are considering these two functions, f, which is s squared plus 1, and j 2s plus 3, if you are looking for probably j of f, then it means that we are going to take the g function, which is 2s plus 3, and wherever we see x, we'll put what? F there. So it means that we'll have s squared plus 1 plus 3. So our g of f, we can also be written as g of f of x will be equal to 2s squared plus 2 plus 3. Then we have 2s squared plus 5. So these are some of the few things we looked at. If you have any questions, you can probably put it in the comment section and we can be able to discuss that. We can be able to go through, would have time to be able to look at it, right? So whilst you are watching, put your question in the comment section so that we can look at it if you have any question, right? So we are going to take our time and take some questions, past questions, and then we'll take our time, you solve it, and then we'll also solve it together, right? So let's look at the first question. So I have this past question. Let's look at the first question. So let's try this question. You can write the question out yourself so that based on what we have looked at throughout, you should be able to try and also solve it yourself. So let's call this example 1. Right, so we'll call this example 1. So it says that given that f of x is s squared plus 1, right, and g of x, right, so this is g of x. G of x is 3x plus 1 all over x minus 1. Now, where x is not equal to 1, I believe that you know why x is not equal to 1. We mentioned in the domain of a function that when you have a rational function that is in the form g of x all over h of s, when h of s becomes equal to 0, then the value of x there will make the function undefined, right? So it means that once the function becomes undefined, then that function does not belong to the set of real numbers, so its domain is not found. So when we say where x is not equal to 1, it means that when x is 1 in that function, the function becomes undefined, right? So this is the question. It says that given that f of x is x squared plus 1 and g of x is 3x plus 1 all over x minus 1, where x is not equal to 1, we have to find I. So find I, right, j of f, and then j of f of 2, right? So how do we solve this question? You can try and solve it yourself, go through the process to solve it yourself, so that once you are able to solve it, you'll be able to look at the expected solution. So why don't you go through solving it yourself? Okay. So I'll give you some few minutes to be able to go through it, try and solve it. Okay, so we know that to solve this question, we must take the function f. So the function f, we can write it as f of x, which is equal to s squared plus 1. And then we can write the function g, which is g of x, to be equal to 3x plus 1 all over x minus 1. Right, so once you've been able to write the function f and the function g, we are doing the composition j, which is for I, j of f. And that implies that we can write it as what? J of f of x, right? So this means that we'll take the function g, and wherever we see s, we'll put the function f there. So that would give us 3, and wherever we see the function x, we'll put f there. So it becomes s squared plus 1 plus 1 all over s squared plus 1 minus 1. So we can simplify this expression by having 3 multiplying s squared as 3s squared, and 3 multiplying 1 as 3, then plus 1, and then the denominator part of the question will have s squared plus 1 minus 1. So that is f of g of x, right? So it means that our f of g of s becomes 3s squared plus 3 plus 1 gives us 4 all over x squared, right? So that is our f of g of x. That is our I part of the question. Then now that we have been able to find g of f of x, right? Sorry, it's rather g of f of x. So supposed to be g of f of x. I think the final two parts is where I've written it in the other way around. So this is supposed to be g of f of x, right? So it means that f followed by g. So g of f of x, right? So we take the function g, and wherever we see x, we put f there. That is what we have done. Now we want to find in the I part of the question g of f of 2. So we write it as g of f of 2, right? Where we'll take g of f of x, and in that case, wherever we see x, we'll put 2 there. So it means that we'll have 3 multiplying, so x is 2, right? And then we'll square it plus 4 all over 2 squared. So it means that g of f of 2 is equal to 2 squared gives us 4. 4 times 3 is 12 plus 4 all over 4, right? So it means that we'll have 16 all over 4. And that means that our g of f of 2 gives us 4. Right, so we've gone through a question where we have looked at a composition. I want you to be able to take time to be able to solve some yourself, right? I want you to take time to be able to solve some yourself. So with this one, I'm going to write a question. I'll pause, right? We'll go through the process, try and solve it yourself as well. Take a book and solve it. And in the case where you have a single value answer, I'll put it in the comment section, right? Let's discuss it in the comment section. I hope it's clear. I hope you are with me. So let me put the question here so that you look at it. Take 5 minutes to solve this question, right? These are all past questions and it will help you. So let's look at this question. Let's try and solve this question. So it's similar to the one we did. So this is example 2. Write it out, right? And then try and solve it. I'm hoping I'll see some answers in the comment section. So it says that the functions, right? The functions f and g are defined, I hope you are writing it. So are defined by f of x implies s squared minus 1. And then we also have another function g of x implying s minus 1. Right, sorry, let me clean this. So it's x minus 1. Okay, good. So we have x minus 1 all over x. Right, now we have to find the first one, f of g, I. And then you have to find g of f. And then you have to find g of f of 2. So try and solve these questions in the next 5 minutes. Take your time, take your exercise book and go through it. And put the answers at the comment section. I'm giving you 5 minutes. Then once you are done, we'll be able to look at the answers. You should have started the first question by now, which is the I part of the question, right? Going through the process. You can give a thumbs up or a like if you are solving the question so that I'll know that you are solving it, right? Try and give a like so that I'll know that you are solving the question. So you are solving a question here. So try and solve the question. Go through the process of solving this question, right? These are questions that we have looked at already. We are considering composition of functions in our videos, and we are looking at how we can revise these. So we are revising these questions. So try and solve these questions so that once you solve them, you are solving them in the next 5 minutes. You are already 1 minute gone. So try and solve the question and then put your answer in the comment section in the next 5 minutes. Once you are able to do that, then we'll solve it together as well. And then you compare with your answers to see whether you are making progress. Two minutes. You have 2 minutes more. Make sure you are solving it. Wherever you are, just take your time and make sure you are solving it. Right. A minute more. A minute more. Okay. Right now, I'm sure you should be putting your answers there. You should be having answers and putting your answers there. I want to see someone put an answer in the comment section, right? At least any of them, especially the third one, you get a value. So, what value do you get for g of f of 2, right? So that we'll be able to solve it. And then once you know that you are on the right track, it means that you are revising, you are doing something, right? So, let's go through the process of solving it together. So we have two functions, right? One of the functions that we have is f. So you can write it as f of x. So mostly the functions are written in an implication form where we have f of x implies x squared minus 1, right? And we have g of x implies x minus 1 all over x. So you can write it in this form. F of x is equal to x squared minus 1, right? And then we also have our g of x. We can write it as that to be equal to x minus 1 all over x, right? By now, you should know what each of these functions represent. So we know that a function that is of the form x squared minus 1, something like this, is a quadratic function, right? And then a function that is of the form x minus 1 all over x is a rational function, right? But in this case, you are asked to find a composite function. The first one is f of g. So what this implies is that we have f, right, of g of x, or in probably expression terms we'll say g followed by f, right? And what this implies is that you take the function f, so that wherever you see the x in the f, we put g of x there. So it means that our function now becomes, right, we take f, so f of g of s becomes equal to f is x squared minus 1. So where we see x, we'll put x minus 1, right, all over x, right? And then we are going to do all this squared minus 1. So what this implies is that the function f of g of x should be equal to the square affects both the numerator and the denominator. So we have x minus 1 all squared all over s squared minus 1, right? And that implies that we are going to have a numerator part, right, which is a quadratic equation. We write it as s squared, right, minus, we put 2 in front of the x, multiply by the x and multiply by the negative, so we are minus 2x plus 1, right, all over s squared minus 1. Let's take this to be over 1. So f of g of x, right? So this implies that once we have this, we can write this by using LCM. LCM is s squared. So s squared goes into itself 1. So we have s squared minus 2s plus 1. And here, 1 will go here, s squared. So minus s squared. Right, so minus s squared. Let me clean it right well. So this minus s squared. Right, so that implies that our f of g of s, right, f of g of s can be written as s squared minus s squared will go away. So we have 1 minus 2x, right, all over s squared. Or you can write it minus 2s plus 1 all over s squared. Both of them are right. So if you got this, right, as your function f of g of s, then you've been able to resolve the composite function f of g. Right, we've been able to resolve the composite function f of g. Now let's consider the second part of the question. So the second part of the question is asking us to find the other way around, which is g of f. So we are looking at g of f. And what this implies is that we have g of f of x, right? And that means that we can write this as, we take g, right? So the function g is x minus 1 all over x. And wherever we see x in that g, we are going to substitute it with s squared minus 1. So we are going to have s squared minus 1, right, minus 1 all over, this time we are going to have s squared minus 1, which is the function f, right, in place of the x in g. So we can write g of f of x as s squared minus 1 all over s squared minus 1. So we have g of f of s to be equal to s squared, right? So this is s squared minus 2 all over s squared minus 1, right? So the numerator part is s squared minus 2, and then the denominator part is s squared minus 1. Now we can substitute, or in the third part of the question, which is I, we are asked to find g of f of 2. So wherever we see x here, we put 2 there. So you have 2 squared minus 2 all over 2 squared minus 1. Right, in this case, we have 4 minus 2 all over, right, the denominator part is 2 squared. Let me write it well. So 2 squared, oh, I wrote it 2 multiplied by 2. So let me write it as 2 squared. So it's 2 squared minus 1, right? And in this case, you have 4 minus 1. So it means that you're going to have 2 all over 3, right? So it means that our g of f of 2 is 2 over 3, right? So it's a function g of f of 2. So I believe you should have 2 over 3 as your answer. If you got that, or you can corroborate what you got for the g of f of 2, then it means that you're on the right track. You are really doing well with the composite functions. Composite functions are very important, as we said, because we looked at the practicality of it, where we considered how you can be able to deliver something, right? So let's consider that. So what are the real applications of composite functions? So in our lessons, we mentioned that the real applications of composite functions, right, which is very interesting. It's not just about solving a question. We need to know why we are solving composite functions, or putting functions together in order to get a composition of a function, right? So we mentioned that in a restaurant, for instance, if you are in a restaurant, right, we can have functions representing things. So let's say the function f of s will represent the food, right, the order, or that the food that's one makes, or the order that one makes in terms of the price. So that can represent the price or the order that one makes, right? So that is what it can represent at the end of the day, right? So that is our f of x. And we can also have our g of x, which can represent the charge for, right, the delivery. So you can have g of x to be the charge of the delivery. And then imagine that in all your restaurants that you have created, depending on the distance, you have an extra charge. So the h of s will represent the extra charge, right? The extra charge for distance. And let's imagine that the restaurant is at Dansoman, and for Dansoman and its environs, the charge is fixed. But then when you are moving, let's say you are going to East Legon, they will charge an extra amount of money, which is represented by the function h of x. As a restaurant owner, you can decide to combine these three functions, right? That you have modeled, you can decide to combine these three functions. And when you combine them, you get a composite function. So one thing you should see is that the food is something you cannot do without. Someone can walk into your shop, right, or walk into your restaurant and decide to order the food, right? So the f of x will be on the inside, right? It is like the main one. And from the f of s, the charge or the delivery or the charge for the delivery will be on the outside. So you have g of f of x, right? And depending on your distance, if you are somewhere around the East Legon area, Blekuma, far away, it means that you'll be charged an extra for the distance covered. So this is what we call a composition of function or a composite function. And that is how applicable these things are, right? So if you model a function on your business, you can decide that once the functions are related together or they deal with the same thing, you can do a composition of the function, right? Such that you get one function in all when you put all the three together. So that is the importance of composition of function, right? Now we have also looked at the domain, the range, and the zeros of a function. So we want to look at what the domain, the range, and the zeros of a function represent, right? So we would use some questions because we've looked at them already. So let's consider this as example 3. So we are given a function f of s to be equal to x minus 1 all over x plus 3, right? And then we are also given a function g of x to be equal to 2x plus 3. Now we are asked to find I, the domain of f of s, and g of x. So we want to find the domain of these two functions, f of x and g of x, right? And then we also want to find the range of f of x and g of x, right? And as well, we would also want to find the zeros. So once we find these three, we'll be able to revise on domain, range, and zeros. So the zeros of f of x and g of x, right? So let's look at how we can find the domain of the function, right? So for domain of the function, we see that when you have a function, right, we are looking at all the x values. So let's take the f of x for instance. So for I, right, f of x is equal to x minus 1 all over x plus 3. So you want to find all the values, right, in the function here that makes the function here defined on the set of real numbers, basically, because that's what we are dealing with. So we know that when we get something like s minus 1 all over 0, then this function becomes undefined, or it doesn't fall under the defined terms of the function, right? Because it's undefined. So we don't want the x here to become, right, a number that will make the denominator 0, right? In this case, negative 3. So all we need to do is that we equate the denominator to 0. And that means that we are going to have s plus 3 to be equal to 0. And that implies that s is equal to negative 3, right? So it means that we can say that the domain of this function, right, is x such that s is a member of all real numbers, right? You can say except when s is equal to negative 3. So that is one way of writing the domain, right? Or we can also write the domain of the function as x such that s is a member of all real numbers where x is not equal to -3. So when we want to write it without the except, then you have to write that x is not equal to, because when x is equal to -3, the denominator of the function becomes what? Undefined, right? And that term that will not really be of benefit to the function or the domain of the function. On the other hand, we have g of x, right? So g of x is equal to 2s plus 3. And then we know that for this, once it's a polynomial function, all polynomial functions except defined on some clear terms, right? When it's defined on some clear terms, and it means that one, we must be able to find the domain on that clear terms. But once it's not defined on clear terms, then it means that the domain will be the domain on all real numbers. So in this case, you are going to say that the domain will be what? S such that S is a member of all real numbers, right? S such that S is a member of all real numbers. So that represents the domain of the function for g of x. So now that we have looked at the domain of the function for f of s and g of s, let's go on to look at the range of the function. So basically for the range of the function, right, when we have x minus 1 all over s plus 3 for f of x, we say if we want to find the range of the function, let y to be equal to f of x, right? Because we know that when y is equal to x minus 1 all over s plus 3, right? S minus 1 all over s plus 3. Let me clean the one and write it. Well, this 3, so s plus 3. Then the range of the functions are all the y values that we get when we put the x in. So you see that in this case, when it's a rational function, right, the denominator cannot be 0. In the same way, in the range, there can be some values that would make the function undefined. So that is what we want to find. So in this case, we can just cross multiply and make s a subject. So we have y multiplying s plus 3 is equal to x minus 1. Right, so you have xy plus 3y is equal to x minus 1. Right, so we want to make s a subject. So we have xy, when we move this here, it becomes minus x is equal to -1 plus 3y. Right, so that implies that we are going to factorize x out. So we have x, right, to be equal to y minus 1, right, and that is equal to -1 plus 3y. Good, so we have all over y minus 1 all over y minus 1, right? So it means that our s becomes equal to -1 plus 3y all over y minus 1. That's very good. So we see that the denominator will not be defined on the terms here, right, when this is equal to 0. So you are going to have y minus 1 to be equal to 0 and y will be equal to 1, right? So it means that the range of the function here would be y such that y is a member of all real numbers, right, except when y is equal to 1 or when y is not equal to 1. I hope that is what you also got. So I can see a comment here, right? Collins is saying that there is understanding. Oh, someone is congratulating me. Calvin, thank you so much, Calvin. And you mentioned the range of the function as you defined it as you've done it well, but you need to actually tell me the range. You don't need to just say it. So you have to say the range is on all real numbers, right, where x is not equal to 1. So that is it. That is it. So you are doing well. So that is the range of the function. So how about when we have the other function g of x? And what was g of x? G of x was 2s plus 3, right? So we have g of x to be equal to 2s plus 3. Put the range of the function there. What would be the range of the function for g of x, which is equal to 2s plus 3? I want to know the range of this function. Put it there. Let me see. What will be the range of this function? So we know that the range of this function, since the domain is on all real numbers, and we say y said that y is a member of all real numbers. As for the zeros of the function, they are very simple. So the third part of the question, which is how do I label it? I, right? So the I part of the question where we are finding the range of the function or the zeros of the function. We just need to equate the function to 0. So f of x is equal to 0. Then you have x minus 1 all over s plus 3 to be equal to 0. So it means we will have the numerator part of the question to be equal to 0. X minus 1 is equal to 0. Then x will be equal to 1. Right? So we know that this is the 0 of the function. The 0 of the function will be x is equal to 1. That's fine. So I think you also got the 0 of the function for the second one. The j is negative 3 on 2 Kelvin. That's very good. So that is a 0 of the function for the second one. Good to know you are really enjoying the lesson. So for a function g of x which is equal to 2s plus 3, we know that we can equate 2s plus 3 to be equal to 0, right? And that implies that we'll have 2x to be equal to negative 3. We divide both sides by the coefficients of the 2, and that means that our x is negative 3 on 2, right? So therefore, our 0 will be equal to negative 3 on 2, rightly so, right? So we are going to look at the last set of questions where we'll consider the injective type of question where they can give you a function and ask you to determine whether it is one-to-one. So I have this nice past question here. I'll write it and I expect that you take your time to go through and determine the answer for me, and then we'll be able to use that to be able to conclude on our live today. It's been a very interesting one. So I think this is example 4. So look at the question, solve it, or write it out and then try and solve it. So it says that a function, right, f of x implies x minus 1 all over 2s plus 3, right? S minus 1 all over 2s plus 3, right? And it is defined, right? It is defined on the set, right, x, which is equal to s is a member of all real numbers, right, except for where x, right, or where x is not equal to negative 3 on 2, right? So we know why x is not equal to negative 3 on 2 by now. So we are asked to state, which is I, states that f is 1 to 1. So you solve this for me. We want to state whether this f is 1 to 1, right? And then we want to determine the domain of the function. So we want to determine the domain and range of the function f. So pause, try, solve, take your time and go through solving them so that we can look at the solutions, right? So we want to find these questions. So I'm giving you some few minutes. Let's do that so that we can be able to conclude on this. We have been able to revise on all the aspects. I might be letting in so much. So let's use the next 5 minutes to be able to do that, right? So I mentioned that math should be fun, right? Math should be interesting. You should be able to know how the mathematics you do relates to the real life examples or scenarios you have. So take your time and go through this, right? Great. So you've been able to determine that the function is one-to-one first and foremost. So now still try and do the domain and the range of the function. Right, try go through the range and the domain of the function. That's nice. Yeah, and that is it. So when you solve for the function f of x, you realize that, right, the a is equal to b, right? That's when you use a and b, a is equal to b. So you can conclude that the function is one-to-one in that case. That is a very good one. So what would be the domain of the function, right? In the first, what would be the domain of the function? Very good. So that is a domain of the function as well. So you've been able to get the domain of the function. You just equate the denominator parts of the function to 0 and then find the value of that x, right? That makes the function undefined. And we see that that is negative 3, 1, 2. So we define it on all real numbers except that which is the negative 3 on 2. And then the range of the function as well can be determined. So we have today in our live session, we have gone through revising most of the things we've done. That is on functions, that is with STEM with Nana, which is the videos that we have looked at. We have considered the definition of function. We have considered the evaluation of function, how we can evaluate functions. We've also looked at the evaluation of functions, that is multiplication, addition, subtraction. We've also considered composite functions, which we looked at how we can compose functions. We've considered the domain of a function and how we can find the domain of the function. Right. So for Monday, we'll be having more videos. We'll be having videos on how we can define bijective function, injective function, and surjective functions. And then we'll also have the inverse of a function. And then we'll also look at how practical the inverse of a function is in real life. Ensure that you don't miss these videos because it will help you. We are in times where you have to do more online studies than probably having personal studies with teachers. So you need to get used to the system where you go online and come to STEM with Senana and then come and get all the videos you want. Very soon we'll have videos on in mathematics as well. We'll have videos in science as well on all the topics that you are supposed to do for SHS1. And it will help you to be able to revise throughout, right? Where you actually need to study on your own, especially in times where you have to be at home during vacations, long vacations, right? So to continue to follow, continue to practice, continue to learn, continue to have more kind of interactions. And before we go, if you have any question, put it in the comment section so that we can discuss it. If there is no question as well, let me know so that we'll have a live again next week, Saturday, 6 to 7. Ensure you invite friends. Make sure you tell them, let them come. This is the time that you learn for free, you would interact for free, you would have an opportunity to practice the things that we put there. And we are also going to put here linear functions, graphing linear functions, and the interpretation of some of the things on linear functions, right? And this will help you because you'll be able to see the graphs very clearly. So make sure that all the videos we put there next week, you are part of it, you are watching it, you are solving questions on them. The questions that they put under the comment section, make sure that you have actually been able to solve them and put them there, right? And then we'll be able to continue. I'm happy that you cannot wait and you are enjoying this lesson. Thank you so much, Calvin. And we will have another time again next week. And sure, you watch all the videos on what we are going to do. We have more videos for you, like we've done all of them, but then we can't put all of them on the YouTube at once. We have to do them little by little. So I'm sure by the time you go back to school, you would have a lot that you would have learned. Thank you so much. And we'll meet again next week. Bye bye.